Space is not empty. It is filled with a silence so heavy that it feels like a physical weight. To the human mind, the solar system is a map of lines and circles, a neat diagram where planets travel on predictable roads. But in reality, it is a violent, silent ocean. And in the center of this ocean sits the Sun. It is a monster of burning gas, a sphere of nuclear fire that holds 99% of the mass in the solar system. It screams with radiation, throwing out waves of heat and light that touch every corner of the dark void. If you were floating close to it, there would be no sound because sound cannot travel in a vacuum. There would only be the blinding white light, brighter than a million welders' torches, and the overwhelming sense of power. On October 29, 2025, the Sun was calm. Its surface, a shifting sea of plasma, churned in its usual rhythm. From the perspective of Earth, nothing seemed wrong. The automated satellites continued their lonely orbits. The giant telescopes in Hawaii and Chile pointed their glass eyes toward the deep black counting stars and tracking asteroids. The world below went about its business, trusting that the sky was watched, that the sentinels were awake. But eyes cannot see through fire. There is a basic rule of geometry that rules the heavens. When you stand in front of a bright light, you cannot see what is hidden directly behind it. In the language of orbital mechanics, this is sometimes called a conjunction. It creates a blind spot, a cone of shadow. Behind the Sun, on the exact opposite side of the solar system from Earth, there is a massive volume of space that is completely invisible to us. Our radio waves cannot punch through the star's interference. Our optical sensors are blinded by the glare. For weeks at a time, anything that travels into this zone disappears from our maps. We call it the zone of exclusion, or simply the blind spot. It is the perfect hiding place. On this specific Tuesday in late October, deep within that blind spot, a shadow began to move. It was not a rock. It was not a comet tumbling through the dark. It was a structure cold and metallic, drifting in the absolute zero of the Sun's shadow. To any observer, it would have looked like a ghost. It reflected no light because it was painted in a black deeper than space itself. It emitted no heat because its systems were frozen, locked in a hibernation sleep. The object had been drifting for months, using the gravity of Jupiter to sling itself inward, falling silently toward the inner solar system. It had timed its arrival perfectly. It entered the blind spot just as Earth swung around to the other side. It moved in the darkness, shielded by the very star that gave Earth life. Inside the object, a timer clicked over. Suddenly, the silence of the machine was broken, not by a roar, but by a hiss. Small thrusters on the side of the hull fired. They did not use burning fire, which might be seen by a stray probe. Instead, they used cold gas, invisible and quick. Hiss, hiss, hiss. The massive object began to rotate. It was a delicate dance. In space, Newton's laws are absolute. For every action, there is an equal and opposite reaction. The gas pushed one way and thousands of tons of metal slowly turned the other way. It aligned itself. It was correcting its course. If a human were floating next to it, they would feel a terrifying sense of scale. The Sun, even from behind, created a halo of plasma around its edges, a ring of fire framing the black disk. And against that ring of fire, this dark shape looked like a shark swimming in deep water. The maneuver was calculated to the millimeter. The object was slowing down. It was dropping from a high orbit into a lower one, tightening its circle around the Sun. This was the most dangerous part of the journey. If it slowed down too much, gravity would win, and the object would fall into the star, vaporizing instantly. If it didn't slow down enough, it would shoot out the other side too fast, missing its target. But there was no pilot to sweat or tremble. The computer controlling the burn was cold logic. It measured velocity in kilometers per second. It measured distance in astronomical units. It adjusted the angle by 0.001 degrees. The burn lasted for 20 minutes, then the thrusters cut off. Silence returned. The object was now on a new path. It was no longer falling, it was hunting. The tension in this region of space was not dramatic or loud. It was the tension of a ticking clock. Orbital mechanics is the math of inevitability. Once an object is set on a path, it will arrive. It is not a question of if, but when. On Earth, scientists were worried about climate change, stock markets, and local politics. They looked at their screens and saw a green status light for the solar system. All clear, the computers said. They did not know that the data was incomplete. They did not know that the glare of the Sun was being used against them. The blind spot is not small. It covers millions of kilometers. A fleet of ships could hide there, and we would never know until they moved out of the shadow. This single object, massive and silent, floated through the void, completely unseen. As October 29th turned into October 30th on Earth, the object completed its turn, it stabilized. Its sensors woke up tasting the radiation streaming past the sun's edge. It was waiting for the geometry to change. The Earth moves at about 30 kilometers per second. The object was moving faster. Slowly, inevitably, the angles would shift, the blind spot would move, and the curtain would be pulled back. Imagine a hunter standing in a dark forest waiting for the sunrise to reveal his prey. That was the situation behind the sun. The blinding glare that protected Earth from the freezing cold of outer space was now acting as a wall. Behind that wall, the trap was set. The universe does not care about intent, it does not care about good or evil. It only cares about mass velocity and gravity. And according to those laws, the collision course was now set. The shadow was no longer just drifting, it was aimed. The silence of the void continued unbroken. The sun continued to burn indifferent to the small metal speck maneuvering behind its back. But the clock was ticking. In a few days, the geometry would align, the object would emerge from the glare. And by the time Earth saw what was coming out of the sun, it would be too late to close the door. To understand the storm surrounding Oumuamua, one must first understand the man standing in the center of the rain, holding nothing but an umbrella of unpopular mathematics. Avi Loeb is not the type of person usually associated with stories about aliens. In the collective imagination, the person shouting about extraterrestrial life is usually an outsider, someone on the fringes of society with a tinfoil hat and a basement full of conspiracy theories. Avi Loeb is the exact opposite. He is the ultimate insider. Walk through the polished, dusty halls of the Harvard-Smithsonian Center for Astrophysics and you are walking through the heart of the scientific establishment. This is a world of oak desks, stacks of peer-reviewed journals, and the quiet, heavy atmosphere of serious thought. For years, Loeb ruled this world. He served as the chair of the Harvard Astronomy Department, the longest-serving chair in the department's history. He has published hundreds of papers on black holes, the formation of the first stars and the early universe. His resume is a fortress of credibility. And yet this is the man who looked at a strange object tumbling through our solar system and dared to say the one word that can ruin a serious career artificial. Why would he do it? Why would a man with such a pristine reputation risk burning it all down? To answer this, you have to look at Loeb's philosophy of science, which stands in stark contrast to how modern academia often operates. Loeb believes that science has lost its soul. He argues that the academic world has become too safe, too worried about image, and too obsessed with accolades rather than truth. In Loeb's view, modern science is like a person looking for their lost keys at night. They only look under the street lamp because that is where the light is, even though they drop the keys in the dark bushes. Scientists study what is popular, what is fundable, and what will get them tenure. They refine known theories rather than chasing wild anomalies. When Oumuamua arrived, it was firmly in the dark bushes. It did not behave like a comet, and it did not behave like an asteroid. It was an anomaly. Most scientists tried to force the object into a category they understood. They tried to invent new theories about hydrogen icebergs or dust bunnies to explain its strange acceleration without gravity. They wanted to keep the keys under the streetlight. Loeb, however, was willing to step into the dark. He argues that if you adhere strictly to the evidence and the evidence rules out a comet and rules out an asteroid, you must be brave enough to consider the remaining option, no matter how uncomfortable it makes you feel. This brings us to the psychological tension at the heart of this controversy. It is the tension between safe science and the spirit of discovery. There is a heavy pressure in academia to conform. If a young student suggests aliens, they might not get a job. If a professor suggests it, they might lose funding. It is a culture that punishes risk. Loeb calls this the giggle factor. It is the tendency of the scientific community to laugh at ideas that sound like science fiction, dismissing them before even looking at the data. Loeb refuses to laugh. He approaches the possibility of alien technology with the same serious, stoic face he uses for black holes. He believes this refusal to investigate is not just lazy, it is dangerous. It represents a failure of the scientific method. He often references Galileo, the Italian astronomer who was persecuted for saying the Earth revolved around the sun. The philosophers of Galileo's time refused to even look through his telescope because they were so sure they already knew the truth. Loeb sees his colleagues as those philosophers. They are so sure Oumuamua was a rock that they refuse to seriously look through the telescope of the artificial hypothesis. This stance comes with a heavy burden. The phrase "extraordinary claims require extraordinary evidence" was popularized by Carl Sagan, and it is the shield used by Loeb's critics. They argue that claiming an object is an alien light sail is a massive claim, so Loeb needs massive proof. Loeb flips this argument on its head. He believes that assuming Oumuamua is just a rock is also an extraordinary claim because we have never seen a rock behave that way. To him, ignoring the data because it is weird is not being conservative, it is being ignorant. There is a profound loneliness in this position. Picture the scene: a distinguished professor sitting in his office at Harvard, surrounded by the silence of his colleagues. While the public is fascinated by his theories, many within his own community have turned their backs. He has been called names, ridiculed in newspapers, and labelled a publicity seeker. For most people, this social rejection would be enough to make them stop, but Loeb seems to be driven by a psychology that is immune to peer pressure. He speaks often of cosmic modesty. This is the idea that humans are arrogant to think we are special. We assume we are the only intelligent life because it makes us feel important, like the centre of the universe. Loeb argues that the universe is vast, old, and likely full of traffic. Believing that we are the only smart things in existence is to him a form of childish pride. He views himself as the adult in the room, telling humanity to grow up and accept that we might be just average intelligence in a crowded galaxy. Ultimately, Avi Loeb represents a clash of eras. He embodies the romantic ideal of the lone explorer, the scientist, who cares only for the raw data regardless of where it leads. But he is living in an era of safe consensus-driven bureaucracy. He is a man willing to be wrong, which is a rare trait. He has stated clearly that if he finds evidence that proves Oumuamua was a rock, he will accept it. But he demands that the evidence be found, not assumed. As the dust settles in the empty lecture halls and the emails of criticism pile up in his inbox, Loeb remains unmoved. He continues to write, to speak, and to look up. He risks his legacy because he believes that the risk of missing the greatest discovery in human history is far worse than the risk of being laughed at. He is betting his entire life's work on the idea that nature is stranger than we allow it to be, and that sometimes the most scientific thing you can do is admit that you might not be alone. To understand the shock of the present, we must first look back at the ghost of the past. Before the world turned its eyes toward Three-Eye Atlas, there was another visitor that broke all the rules. It was the first sign that our solar system is not a lonely island, but rather a busy intersection in the galaxy. This story begins on a quiet night in October in the year 2017. High atop the Haleakala volcano in Hawaii, the Pan-STARRS telescope was doing its job scanning the dark sky for near-Earth objects. These are usually asteroids or comets that might pose a threat to our planet. On October 19th, Robert Warwick, an astronomer, looking at the data, noticed a point of light. It was a faint blurry dot moving across the background of stars. At first it looked like any ordinary rock, but when astronomers calculated its path, the math did not make sense. Everything in our solar system orbits the sun. Even the comets that travel far out into the dark eventually turn around and come back held by the gravity of our star. But this object was different. It was moving at a speed of 26 kilometers per second relative to the sun before it even entered our neighborhood. When it dived toward the sun, gravity whipped it up to a staggering 87 kilometers per second. The shape of its path was not a circle or an oval, it was a hyperbola, an open line. This meant only one thing: the object was not from here. It had come from deep interstellar space, fell toward our sun, and was already on its way out, never to return. They named it Oumuamua. In the Hawaiian language, this word roughly translates to a messenger from afar arriving first. It was a poetic name for a mystery that would haunt scientists for years. As telescopes around the world swung to look at this fleeing visitor, the data became stranger and stranger. The most confusing piece of evidence came from the light curve. As an object rotates in space, the sunlight reflects off its surface. If the object is a round ball, the brightness stays mostly the same. But Oumuamua was not a ball. The brightness of Oumuamua changed dramatically every 7 to 8 hours. It would get bright and then it would dim until it was almost invisible, dropping by a factor of 10. This huge shift in brightness told us about its shape. For the light to change that much, the object had to be extremely long and thin. Artist illustrations famously depicted it as a reddish cigar, perhaps 10 times longer than it was wide. Others suggested it might be shaped like a flat pancake. Whatever it was tumbling. This is the image that sticks in the mind: a dark red cigar-shaped rock, hundreds of meters long, tumbling silently end over end through the cold vacuum. It was not spinning smoothly like a planet. It was tumbling chaotically. This motion suggested a violent past. Perhaps it was a shard of a planet that had been torn apart by a dying star 1 billion years ago, thrown out into the emptiness to drift alone for eons. The strangeness did not stop with the shape. As Oumuamua moved away from the sun, It did something impossible for a simple rock. It sped up. Gravity should have slowed it down as it tried to escape the sun's pull, but the data showed a slight extra push. In the world of comets, this is normal. When a comet gets close to the sun, the ice on its surface turns to gas, creating jets that act like rocket thrusters. But comets have tails of dust and gas. Oumuamua had no tail. It was just a point of light. There was no cloud of dust, no visible gas, yet something was pushing it. This non-gravitational acceleration sparked wild debates. Was it releasing pure hydrogen gas that was invisible to our telescopes? Was it a solid nitrogen iceberg? Or as some daring scientists suggested, was it artificial? Was it a light sail pushed by sunlight, a piece of defunct alien technology drifting through the stars? We never got a clear answer. That is the tragedy of Oumuamua. It was a story of too late. By the time we realized what it was already passing the orbit of Mars, fading into the dark. We could not send a rocket to catch it. We could not take a close-up photo. It was a missed opportunity that left the scientific community with a deep sense of frustration. We were left with only blurry data and unanswered questions. It was a ghost that passed through the room before we could turn on the lights. This brings us to the present and to the object we now call 3I Atlas. The contrast between the two visitors could not be sharper. Oumuamua was defined by its soreness and its dead chaotic tumbling. It felt like a piece of wreckage, a graveyard marker floating through the void. It ignored us completely. It showed no signs of life, no structure beyond its strange shape, and no signal. It was a passive traveller. 3I Atlas is different. When 3I Atlas arrived, we were ready. We caught it earlier in its approach, but more importantly, the behaviour of Atlas is not like the silent tumbling of its predecessor. The light curve data for 3I Atlas is far too steady. It is not tumbling wildly end over end. It is rotating with a precision that feels almost mechanical. Furthermore, Oumuamua was dark, reflecting very little light like old asphalt. 3I Atlas is strangely reflective, suggesting a surface that is not made of simple dusty rock. And while Oumuamua left us wondering about the mysterious push that accelerated it, 3I Atlas is not waiting for us to guess. As we have seen in the early observations, the energy readings coming from this new object are not just reflections of the sun. Oumuamua felt like a stone thrown through a window, an accident of nature. 3I Atlas feels like a knock at the door. The ghostly cigar shape of 2017 taught us that we need to watch the sky more closely. It taught us that interstellar objects are real and that they are weird. But it also lulled us into thinking that these visitors are just dead rocks or icebergs. It prepared us for debris. It did not prepare us for something that might be watching us back. The tumbling of Oumuamua was the motion of something dead surrendering to the laws of physics. The motion of 3I Atlas, smooth and stable, suggests something else entirely control. We are no longer looking at a missed opportunity. We are looking at an event that is unfolding right now, and this time the visitor is not staying silent. As the object known as 3I Atlas crossed the invisible boundary that separates the deep frozen dark of the outer solar system from the warmer active neighbourhood of the inner planets, the scientific community prepared for a show. They expected a standard celestial performance. They expected the heat of the sun to strip away layers of ice, creating a fuzzy halo of gas and a long, beautiful tail streaming away from the star. They expected the signature chemical fingerprints of water, carbon dioxide, and dust. They waited for the familiar. Instead, Atlas gave them a ghost story. The first thing that shattered the expectations of astronomers was the brightness. In the cold vacuum of space, most asteroids are dull, rocky things. They are like charcoal briquettes floating in the dark, absorbing almost all the sunlight that hits them and reflecting very little back. Comets are slightly better, often described as dirty snowballs, but even they are usually dim until they get close enough to the sun to start melting. Atlas was different. As it tumbled closer, it did not just reflect light, it seemed to catch it, amplify it, and throw it back with an intensity that made no sense for its estimated size. It was dazzlingly bright. If a normal asteroid is like a piece of asphalt on a road, Atlas was like a polished mirror, or a sheet of fresh wet ice. It flickered with a manic rhythm, pulsing brighter and dimmer as it spun. This pulsing light curve gave scientists their first clue about its shape. Most space rocks are round or slightly potato-shaped, but the light from Atlas dimmed and brightened so dramatically by a factor of 10 that it suggested an extreme shape. It had to be incredibly long and thin, tumbling end over end like a discarded pencil, or perhaps wide and flat like a pancake flipping through the air. This extreme reflectivity, known to astronomers as high albedo, suggested a surface that had been smoothed to perfection or coated in something that acted like metal. It refused to be a dull rock. It wanted to be seen. Then came the issue of the tail. This was the feature that caused arguments in observatories all over the world. By the known laws of physics, a comet tail is formed by the solar wind. The sun constantly blows a stream of charged particles outward. When a comet heats up, it releases gas and dust. The solar wind hits this cloud and pushes it away, meaning a comet's tail should always point away from the sun like a windsock at an airport showing the direction of the breeze. Atlas, however, displayed what is rarely seen in anti-tail. While it did have a faint, barely visible trail of dust behind it, there was a distinct sharp spike of light pointing in the exact opposite direction directly toward the sun. It looked as though the object was moving into a stiff wind with a long scarf blowing forward instead of backward. Now scientists knew that an anti-tail is often an optical illusion, a trick of perspective caused by the angle of the Earth relative to the comet's orbit. It usually happens when the Earth crosses the plane of the comet's path, making the wider fan of dust look like a spike pointing the wrong way. But the geometry of Atlas was stubborn. The anti-tail persisted longer than the geometry said it should. It looked distinct, sharp and intentional. It looked like a prow cutting through the waves of the solar wind. It gave the unsettling impression that the object was not just drifting but driving. The dust particles around it were behaving strangely too. Usually comet dust is a chaotic mix of sizes, but the high-resolution images, fuzzy as they were, hinted at a uniformity. The dust particles dancing against the solar wind seemed to be of a specific size, large and heavy, resisting the push of the sun more than the fine powder usually found in comets. These heavy grains lingered, refusing to be blown away easily, creating a halo that defied standard models. But the deepest mystery, the one that truly kept the researchers awake at night, was the silence. Not the silence of sound, but the silence of light. When astronomers want to know what something is made of, they do not need to go there and touch it. They use spectroscopy. They take the light reflecting off the object and run it through a prism, breaking it into a rainbow of colours. Every chemical element, hydrogen, oxygen, carbon, iron, absorbs light at specific points on that rainbow, leaving dark bands. These bands are like a barcode. If you see the barcode for water, you know there is water. When the telescopes broke down the light from Atlas, they waited for the barcode of a comet. They expected to see the heavy absorption lines of water vapour indicating that ice was melting. They expected the signatures of carbon monoxide or methane, the volatile gases that usually hiss off a comet when it gets warm. The readout came back flat. There was no water. There was no carbon dioxide. There was no dust of the type they understood. The object was spectrally silent. It was moving through the solar system, accelerating as it fell toward the sun, yet it was bone dry. This created a paradox that was impossible to reconcile. To move the way it was moving, changing its speed slightly in a way that gravity alone could not explain. It had to be off-gassing. It had to be shooting out jets of gas to act as tiny thrusters pushing it along. That is how comets get an extra boost. The gas acts like a rocket engine. But if it was shooting out gas, the spectrographs should have seen it. The telescopes should have detected the shimmer of water molecules or the chemical trace of carbon. If it was a rock, it should be descent, but it should follow a perfect gravitational curve. It did not. It was accelerating. If it was a comet, it should accelerate, but it should be screaming with the chemical signature of melting ice. It was silent. It was a dry object acting like a wet one. It was a rock acting like a rocket. The lack of water vapour was ghostly. It implied that the surface was something unknown, something that did not react to the sun's heat in the way natural materials do. The surface was seemingly inert, yet the object was alive with motion. It was as if the object was wrapped in a shield that prevented evaporation, or perhaps it was made of a material that the sun simply could not touch. As it swung past the sun bathed in radiation that would boil the oceans off a planet, Atlas remained chemically mute. It offered no clues to its origin. It was just a bright, silent sliver of light pointing a spike toward the star it was escaping, refusing to evaporate, refusing to explain itself, and defying the very definition of what a celestial body should be. It was a puzzle box that had been welded shut, spinning through the dark, daring us to understand it. It was a rendezvous that should have rewritten the history books. As the object known as Oumuamua tumbled away from Earth, accelerating back out toward the cold darkness of deep space, it did not simply vanish into the void immediately. Before it left our neighbourhood entirely, it had one final crucial appointment. It was heading for the orbit of Mars. To the astronomers tracking the object, this was the golden opportunity. while the telescopes on Earth had struggled to capture clear images of the object, seeing it only as a faint flickering point of light against a backdrop of stars. Mars offered a front-row seat. Orbiting the red planet was one of the most sophisticated pieces of technology humanity has ever built, the Mars Reconnaissance Orbiter. This spacecraft is not just a satellite, it is a spy in the sky, a photographer of unparalleled skill. On board this orbiter sits a camera known as HiRISE. This is not the kind of camera you hold in your hand. It is a massive reflecting telescope, a half-meter wide, capable of seeing things on the surface of Mars with incredible clarity. From hundreds of kilometers up, it can spot a dinner table sitting in the red dust. It has spent years mapping the Martian surface, revealing avalanches, ancient riverbeds, and the landing sites of our rovers. If there was anything capable of taking a true close-up photograph of our interstellar visitor, it was HiRISE. The mathematics of the encounter were beautiful and precise. Trajectory models showed that Oumuamua would pass relatively close to Mars. The timing was tight, but the geometry worked. On the second day of October, the paths of the spacecraft and the interstellar object would align. The sun would be in the right position to illuminate the object, and the background would be dark enough to provide contrast. It was the perfect setup for a portrait of the stranger. Expectations were incredibly high. For weeks, the scientific community buzzed with a specific kind of nervous energy. We were finally going to see it. We were going to see if it was a rock, a shard of ice, or something that looked like nothing we had ever seen before. The commands were prepared, the sequences were uploaded to the computer brains of the orbiter. Millions of miles away in the silence of space, the Mars Reconnaissance Orbiter received its orders. It turned its gaze away from the rust-coloured canyons of Mars and pointed its lens toward the black abyss. It was ready to capture the ghost. Then the waiting began. Data transmission from Mars is not instantaneous. It travels at the speed of light, but the volume of data from a high-resolution camera is massive. It takes time to download, process, and clean the images. Scientists refreshed their screens, they checked the servers, they waited for the image that would appear on the cover of every magazine in the world. But the image never came. When the data from that specific window on October 2nd was finally queried, the result was a heart-stopping anticlimax. The database returned nothing of value. There was a silence where there should have been a scream of discovery. The searches returned no results, or showed images of empty star fields where the object should have been. This is where the story shifts from a scientific challenge to a deepening mystery. Why was the image missing? The official explanations were vague, lost in the fog of bureaucracy and technical jargon. Some reports suggested that there were tracking errors, that the object was moving too fast, and the camera simply looked in the slightly wrong direction. Space is big and Oumuamua was small. Missing it by a fraction of a degree means missing it entirely. It is like trying to shoot a bullet out of the air with another bullet. However, others pointed to more frustrating human reasons. There was talk of bad timing with orbital cycles or issues with the deep space network than the massive radio antennas on Earth that talk to spacecraft. There were whispers about funding gaps and government shutdowns that disrupt the smooth operation of these delicate missions. When the government shuts down non-essential operations, cease. Was the photo of the century lost because of a budget dispute in Washington? Was it a victim of a computer glitch, or was it simply incompetence? A fat finger error, where someone typed a coordinate wrong. The silence from the archives felt heavy. It did not feel like a simple mistake, it felt like a missing puzzle piece that had been deliberately removed from the box. The Mars Reconnaissance Orbiter is a machine of extreme precision. It rarely misses. The fact that it failed to capture the one object that mattered most at that specific moment left a hollow feeling in the stomach of the research community. Imagine the surface of Mars below ancient and dusty watching this silent drama. The camera turns the shutter triggers, but the digital memory remains blank. It creates a ghost in the records. The ghost of October 2nd is not a spirit but a void in the data. It is the picture that does not exist. This absence of evidence forced scientists back to the drawing board. Without that photo, they were left with only the light curves, the flickering brightness measured from Earth to guess the shape of the object. If HiRISE had caught it, we would know if it had windows, craters, or engines. We would know if it was a jagged rock or a smooth cylinder. Instead, we were left with an artist's interpretation and a folder on a server that was effectively empty. The no results message on the computer screens felt like a door slamming shut. Oumuamua had passed the final checkpoint. It had survived its brush with the sun, it had flown past Earth, and it had slipped past the best camera at Mars like a thief in the night. It was almost as if the object refused to be photographed, staying just outside the frame, hiding in the glare or moving just fast enough to blur into invisibility. For those who looked for the truth, the missing Mars evidence is the most frustrating chapter of the entire saga. It is the smoking gun that jammed. It leaves us with a lingering, uncomfortable question. Did we simply miss it because space is hard, or did we miss it because we were not meant to see it? The orbiters continued to circle Mars, taking beautiful pictures of rocks and sand, but the traveller was gone, carrying its secrets back into the deep dark, leaving behind only the ghost of what we might have seen. The ship falls. That is the only way to describe the sensation. Even though we are floating in the weightlessness of the void, we are not simply dropping, we are surrendering to the most massive object in our solar system. To go outward to reach the frozen silent edges of the galaxy, we must first dive into the fire. This is the paradox of the Oberth effect. It is the counterintuitive rule that governs deep space travel. To gain the most energy, you must be moving as fast as possible when you ignite your engines, and the only place to generate that kind of raw natural speed is at the bottom of a massive gravity well. We are falling toward the sun, allowing its immense mass to pull us in, turning our potential energy into kinetic fury, the meditation of the bicycle. To truly understand why we risk incineration to fly so close to the star, we must look at a simple earthly analogy. Imagine you are riding a bicycle. Picture yourself on a long, flat stretch of road. You are pedaling at a steady, comfortable pace. If you decide to sprint, to stand up and pedal as hard as you can for 10 seconds, you will speed up. You invest a certain amount of chemical energy from your muscles, and the bike gains a specific amount of speed. It is a simple linear transaction. 1 unit of work gives you 1 unit of result. The air is still and the effort feels heavy. Now imagine a different scenario. You're at the top of a massive steep hill. You let go of the brakes and begin to roll. Gravity takes hold of you. You pick up speed effortlessly, 10 miles per hour, 20-30. The wind is rushing past your ears. The tyres are humming against the asphalt. You're already moving incredibly fast purely because you surrendered to the slope. Now right at the bottom of the hill, at the very moment you are moving at your maximum speed, you stand up and pedal with that same burst of energy you used on the flat road. The result is magic. That same amount of effort produces a much larger change in your final total energy than it did on the flat road. Because you're already moving fast, the mechanical work you do is incredibly efficient. You're not just pushing against the ground, you are multiplying your momentum. You shoot up the next hill with a velocity that feels impossible, carrying you far further than your legs alone could ever take you. This is the physics of kinetic energy. The mathematical rule states that energy is proportional to the velocity squared. This means that adding speed when you are already fast is worth far more than adding speed when you're slow. We are the cyclist, and the sun is the ultimate hill. Gravity as a river, not a wall. Humanity has spent most of its history fighting gravity. It is the chain that binds us to the Earth, the heavy hand that makes liftoff so difficult and expensive. Every rocket launch we have ever watched is a violent struggle to break free from gravity's grip. But out here in the silence of the void, gravity changes its nature. It is not a cage, it is a resource. It is a current of potential energy flowing through the invisible architecture of space-time. A skilled navigator does not fight the current, they ride it. By falling towards the sun, we are harvesting the star's energy. We are stealing a tiny fraction of its momentum, though the sun is so large it will never notice the loss. This turns the star into more than just a source of light or heat. It becomes a component of our engine. It is a massive silent flywheel that we can grab onto to fling ourselves into the dark. There is a profound elegance to this. We are not brute forcing our way through the galaxy with massive inefficient rockets. We are cooperating with the physics of the universe. We are using the curvature of space itself to do the heavy lifting. It transforms space travel from a battle against nature into a dance with it. We fall to rise. The descent to perihelion. As we approach the critical moment, the environment outside the hull becomes terrifying. The sun, usually a polite yellow coin in the sky, has grown into a wall of boiling plasma. It dominates everything. The light is no longer just illumination. It is a physical weight, a pressure that pushes against the ship. The thermal shields are the only things keeping us alive. They are ablating, purposefully burning away layer by layer to dissipate the ferocious heat. Sensors scream warnings about radiation spikes and magnetic turbulence. The ship vibrates not from air resistance, there is no air here, but from the sheer violence of the solar wind and the gravitational tidal forces tugging at the hull. We are the diver on the highboard, falling faster and faster toward the water. The anticipation is agonizing. We watch the velocity readout climb: 50,000 kilometers per hour, 100,000 kilometers per hour, 200,000 kilometers per hour. The numbers blur. We are falling so fast that time itself seems to dilate, a side effect of relativity that becomes measurable at these velocities. The universe outside is warping, bending around the gravity of the star, the solar oath. Then we reach it, perihelion, the point of closest approach, the bottom of the hill. This is the moment of the solar oath. It is the commitment. Once we fire the engines here, there is no turning back. Our trajectory will be altered so radically that we will be flung out into the interstellar void. If the engines fail now, we remain trapped in this fiery loop forever. If they succeed, we are exiled from home. The computer triggers the burn. The engines roar to life. But this isn't a normal acceleration. Because of our extreme speed, every second of thrust provides a massive return on investment. We are dumping energy into the propellant, and because the propellant is moving so fast along with the ship, the kinetic energy grows exponentially. It feels like a slingshot that's snapping. Inside the ship, the G-forces press us into our couches, but it feels different than a launch from Earth. This is a release. We are adding speed to speed. We are taking the massive velocity the sun gave us for free, and we are paying it forward, compounding it. For a few minutes, we are the fastest objects ever made by human hands. We are riding the edge of a distinct mathematical curve, a hyperbola. It is a shape of perfect geometry, a line that comes in from infinity, kisses the face of the star, and then sweeps out toward infinity again. It is a line that never closes, a path that never returns. The departure, and then the engines cut off. The burn is complete. Silence returns, but the feeling has changed. We are no longer falling, we are climbing. We shoot past the sun, whipping around its backside. The star, which moments ago filled our entire vision with terrifying fire, now begins to shrink rapidly behind us. We have stolen its speed. We are moving outward now, faster than a bullet, faster than a comet. The heat begins to fade. The radiation alarms quiet down. We have survived the dive. We look back at the sun, not as a master, but as a launch pad. We used its own strength to escape it. The bicycle has reached the bottom of the hill, the rider has sprinted, and now we are coasting up the other side with enough momentum to carry us out of the solar system forever. We drift into the cold, carrying the stolen fire of the sun, in our velocity bound for the endless dark. To understand why this specific object frightened the scientific community more than any other, you first have to understand the board on which the game is played. We often see models of the solar system in classrooms, plastic balls hanging on wires, or a flat picture in a textbook where the planets sit still in their distinct lanes waiting to be looked at. But that is not reality. The solar system is a machine of constant, violent and complex motion. It's a terrifyingly precise clockwork mechanism where every gear is spinning at a different speed and nothing ever sits still. Earth travels around the sun at roughly 67,000 miles per hour. Mars moves slower, taking nearly 2 years to complete a circle. Venus moves faster. Jupiter, the massive king of the outer system, moves at its own majestic pace, dragging dozens of moons with it. To draw a straight line through space is easy, but to draw a line that intersects with 3 or 4 of these moving targets all at the exact moment they happen to be in that specific spot is a challenge that requires more than just luck. It requires timing. When astronomers finally mapped the full trajectory of the visitor, they did not just see a straight line coming in and going out. They saw a path that seemed to possess a strange, unsettling intelligence. The object did not just fall into our system randomly. It entered from a very specific direction, dipping into the gravity well of the sun, and then performing what looked like a sightseeing tour of the most significant worlds in our neighborhood. The object plunged toward the sun, accelerating to incredible speeds. As it whipped around the star, it did not head back out into the empty void of the southern sky where there is nothing to see. Instead, it shot upward, piercing the flat plane where the planets live. And this is where the math becomes staggering. The trajectory of the object brought it incredibly close to the orbit of Earth. Then it passed within a relatively short distance of the orbit of Mars. Finally, its exit path aligned almost perfectly with the orbit of Jupiter. It was like watching a tourist visiting a city who knows exactly which monuments to visit and in what order. It did not waste time on the empty spaces, it went where the action was. Scientists began to calculate the odds. In the vast 3-dimensional ocean of space, you can enter from any direction. You can enter from above the solar system, from below, or from any degree of the 360-degree circle surrounding us. The amount of empty space is terrifyingly huge. The planets, by comparison, are tiny specks of dust floating in a massive cathedral. Most rocks that enter our system simply fall through the darkness, seeing nothing hitting, nothing, and leaving without ever coming near a planet. To calculate the probability of a random rock falling from the stars and accidentally passing this close to the habitable zone, the area where Earth and Mars reside, and then aligning with Jupiter, the astronomers had to run thousands of computer simulations. They simulated millions of random asteroids entering the solar system from random directions. They watched to see how many of them would naturally follow the path that this visitor took. The computer spit back a number that made everyone in the room go silent. The probability was roughly 1 in 500. To write that out as a percentage, it is 0.005%. This number is the boundary between what we call coincidence and what we call design. If you roll a dice and get a 6, that is chance. If you roll a dice 10 times and get a 6 every single time, you begin to suspect the dice is loaded. This visitor was rolling a 6 over and over again. Think of it this way. Imagine you are standing at one end of a football field. At the other end, there are 3 people running back and forth at different speeds. You are blindfolded. You have a needle in your hand. You throw the needle across the field. What are the odds that the needle will not only travel the full distance, but will also pass through the buttonholes of the shirts of all 3 running people? It is technically possible, but it is so unlikely that if it happened to, you would assume the person throwing the needle was not actually blindfolded. You would assume they were aiming. You would assume they calculated the speed of the runners and the trajectory of the throw. This is the argument of the architecture of coincidence. A random rock from interstellar space has no reason to care about Earth, Mars, or Jupiter. A random rock follows the laws of gravity and motion, nothing else. It does not care about scenery, it does not care about life. However, the path of this object allowed it to sweep past the only 2 planets in our system that are capable of supporting life as we know it, Earth and Mars. It passed close enough to scan them if one were inclined to think in terms of technology. Then it used the massive gravity of Jupiter to stabilize its exit, like a hiker grabbing a tree branch to swing across a river. This brings us to the concept of the local standard of rest. This is a term astronomers use to describe the average motion of stars in our neighborhood. Most stars and the objects that orbit them move in a general flow like cars on a highway, all going the same direction around the center of the galaxy. This object was not moving with the flow. It was sitting almost perfectly still in the galactic sense, waiting for our solar system to slam into it. But the planetary tour suggests it wasn't just waiting. The specific angle of entry meant that the solar system didn't just hit it. We hit it in a way that allowed the object to thread the needle of our planetary orbits. If this was a random event, it is the most fortunate random event in the history of astronomy. It suggests that the universe is so full of rocks that eventually one will accidentally look like a spaceship conducting a survey. It implies that if you throw enough stones into the dark, one will eventually hit a target. But there is another view. If you were sending a probe to a new solar system, you would not want to waste energy. You would want to use the gravity of the star to speed you up. You would want to fly past the planets in the Goldilocks zone, the area not too hot and not too cold, because that is where you might find water or plants or radio signals. You would want to get a look at the gas giants because they protect the inner system. You would plot a course exactly like the one this object took. The difference between a rock and a machine is intent. A rock falls where gravity pulls it. A machine goes where it is sent. When we look at the 0.005% probability, we are forced to ask a difficult question. Why would a rock choose to visit the most interesting things in the solar system? It wouldn't. A rock has no curiosity, it has no desire to explore, but a designer does. The vast emptiness between worlds is usually a barrier. It keeps solar systems isolated. It makes travel difficult and lonely. But for this object, the emptiness was not a barrier, it was a highway, and it seems to have known exactly which exit to take to see the sights. The alignment was too precise, the timing too perfect. It moved with the elegance of a dancer, not the tumbling chaos of a stone. As the object began to leave our neighborhood heading back out into the dark, the math left a lingering, uncomfortable feeling in the minds of those who studied it. We are used to chaos. We are used to things bumping into each other randomly in the night. We are not used to the precision of a thread going through 3 moving needles. We are not used to the architecture of such a perfect coincidence. It felt less like a discovery and more like we had just been watched. This entire dramatic transformation was an event unseen by any human eye or telescope. It happened in the blinding glare of the sun, a place where Earth-based observatories cannot look. We could only track the object as it approached this hidden stage and then pick up its trail again as it emerged from the other side. The most important moment, the climax of its journey through our solar system, happened in complete secrecy. As the object plunged toward its closest approach, the forces acting upon it became extreme. The sun's gravity was pulling it in, stretching and stressing its structure. At the same time, the solar radiation was immense, heating its surface to thousands of degrees. This was a trial by fire. For a simple rock or comet, this would be the moment of destruction or dramatic change. For this object, it was something else entirely. At the exact point of perihelion, the moment of closest contact, something extraordinary happened. The object, which had been a dark reddish and hard-to-see shape, suddenly changed. It flared. This was not the slow brightening of a comet as it gets warmer. This was a sudden, violent and brilliant flash, and the colour was all wrong. Instead of the yellow-white glow of reflected sunlight or the green haze of a normal comet, the object erupted in a stunning, intense and brilliant shade of blue. It was a deep, energetic blue, the kind of light you see in a welder's arc or a bolt of lightning. It was the colour of immense energy. This blue shift was a complete metamorphosis. In an instant, the object transformed from a passive visitor into an active, glowing spectacle. A vast plume of material glowing with this same blue light streamed away from it, pushed by the intense solar wind. It looked less like a rock and more like a blue hot needle threading its way around the sun. This spectacle hidden from us forces us to ask the most important questions. What could cause such a specific and powerful blue light? One theory is that this was a natural but very rare chemical reaction. The object, if it were rich in carbon, might have been burning in a way. As the sun superheated its surface, it could have vaporized huge amounts of carbon. When carbon gas is heated to extreme temperatures, it can glow blue. Perhaps we were seeing the object shed its outer layer in a massive high-temperature outgassing event. This blue hot gas pushing away from the object would have acted like a powerful rocket engine. This would explain the object's other great mystery, its strange acceleration. When the object emerged from the sun's glare, it was moving faster than it should have been. It was accelerating as if something was pushing it. This blue flare, this eruption of vaporized carbon would have been that push. It would be a natural explanation for the object's weird behavior. But there is another, more shocking possibility. What if the blue light was not a natural reaction? What if it was an engine? In our own science, the colour blue is often associated with high-energy propulsion. An ion engine, for example, uses electricity to create and accelerate a stream of charged particles, which often glows blue or violet. This is one of the most efficient forms of propulsion we know how to build. What if the object was not a rock at all, but a craft? What if its close pass of our sun was intentional in this idea? The object was performing a gravity assist maneuver, using the sun's gravity to sling itself to a new higher speed. And at the exact moment of closest approach, it fired its own engine to get the biggest possible boost. The blue flare was not the object's surface burning away, it was the exhaust from its drive. This idea is deeply unsettling, but it also fits the facts. It would explain the suddenness of the flare, its intense blue colour, and the powerful non-gravitational push that changed its speed. It would mean the object was in control of its journey. Whichever theory is true, the visual spectacle must have been incredible. For a few short hours, the object was a tiny artificial blue star, bathed in its own powerful light. This light was not just visible blue, it would have been accompanied by a blinding storm of invisible ultraviolet radiation. This intense radiation would have scoured the object's surface, sterilizing it and cleaning it of any interstellar dust it had collected for millions of years. The metamorphosis was complete. The object had been transformed. The heat, the radiation, and the blue flare itself had changed its surface. When it emerged from the sun's glare, it was not the same object that had gone in. It was cleaner, perhaps more reflective, and it was moving with a new, mysterious purpose, pushed by a force we can only guess at. The most critical event of its visit, the moment that defined its entire journey, remained its greatest secret, a blue flare hidden in the darkness. From theory to reality, we have spent the last 8 parts of this journey exploring the why and the how. We have looked at the history of our solar system, the strange behaviour of the planets, and the mathematical models that suggest something massive is lurking in the dark. We have drawn diagrams and written equations on blackboards, but equations, no matter how beautiful they are just ink on paper. They are not reality. Not yet. In science, you can have the most elegant theory in the world. You can explain the movement of every star and the wobble of every planet. But until you can predict a future event and have that prediction come true, it is just a story. Now we stop telling stories. Now we start looking at the sky. This brings us to the most critical moment in this entire investigation of the video. Verification window. The scientific method in action. It is important to clarify one thing before we move forward. We are not asking you to believe us. Science is not a religion. It does not require faith, it requires observation. In religion, you believe first and hope to see later. In science, you calculate first and then you demand proof. The scientific method is a strict teacher. It says if your theory is true, then X must happen at time Y. If X does not happen, the theory is wrong. It does not matter how much we like the theory. It does not matter how much time we spent on it. If the observation fails, the theory dies. For our hypothesis regarding the dark companion of the Sun, the mathematics point to a very specific time frame. The orbital dynamics calculated over thousands of years of planetary motion suggest that this object will reach its nearest point to the Sun perihelion between November and December of the year 2025. Defining the window. What exactly is the verification window? Think of it like waiting for a train. You know the schedule. You know the train is supposed to arrive at the station between 2:00 p.m. and 2:15 p.m. That 15-minute block is your window. If you stand on the platform during that time and see nothing, you know the train is late or it does not exist. For us, the platform is Earth. The train is a massive invisible source of gravity and energy, and the schedule is late 2025. Specifically, we have calculated a 60-day period starting on November the 1st and ending on December 31st. During these 60 days, the interaction between this dark object and our Sun will be at its peak intensity. This is not a collision, they will not crash into each other. It is a grazing passage in terms of gravitational fields. What are we looking for? If this object is made of dark matter, or is a dead star like a neutron star or black hole, we cannot see it with normal eyes. We cannot just point a standard telescope at it and take a picture. It does not reflect light like a planet. It does not burn bright like a star. It is the ultimate stealth object. So how do we see the invisible? We look for the shadow it casts and the wake it leaves behind. We are looking for 3 specific signals during this window. 1. The gravitational tremor. First, we look at the Sun itself. The Sun is a giant ball of fluid plasma. It is not solid. When a massive object passes near a liquid body, it creates tides, just like the Moon creates tides on Earth's oceans. During November and December, we are looking for a solar tide. We expect to see the shape of the Sun distort slightly, by perhaps only a fraction of a percent. We are looking for the surface of the Sun to bulge outward toward the incoming object. This requires precise measurements of the Sun's diameter. 2. The magnetic short circuit. The Sun has a massive magnetic field that stretches far out into space. If our theoretical object also has a magnetic field, which it should, the 2 fields will interact. Imagine 2 magnets engaging. You can feel the resistance before they touch. When these magnetic lines cross, they snap and reconnect. This releases energy. We are predicting a sudden, unexplained spike in X-ray and ultraviolet radiation coming from the solar corona, the Sun's outer atmosphere. This spike will not look like a normal solar flare. It will look different, sharper, faster, and coming from a specific angle. 3. The barycenter shift. The barycenter is the center of gravity of the solar system. Usually this point moves very slowly as Jupiter and Saturn orbit. However, if a new massive object enters the inner solar system, that center of gravity will jerk suddenly. We verify this by tracking the positions of space probes like Voyager and the Mars rovers. If their radio signals arrive a fraction of a second earlier or later than expected, it means the Earth has moved in a way we did not predict. The global watch telescopes turning in unison. This is where the human element becomes beautiful. Across the globe, preparations are already underway. This is not the work of one lonely scientist in a basement. This is a planetary effort. Imagine the scene on the high mountains of the world. On the summit of Mauna Kea in Hawaii, above the clouds, giant white domes are rotating. In the dry Atacama Desert of Chile, radio telescope dishes are tilting together, moving like a field of mechanical sunflowers turning toward the Sun. They are all still ignoring the rest of the universe. For these 2 months, they are not looking at distant galaxies or nebulae. They are all focused on our own backyard. They are filtering out the noise of the cosmos to listen for one specific hum. The computers are set, the algorithms are written. We are using spectroscopy, which is the science of breaking light into colors to see what elements are present. We are looking for spectral lines fingerprints in the light that shouldn't be there. The signal in the noise. The hardest part of this verification is noise. The sun is a very noisy neighbour. It is constantly screaming out radiation heat and radio waves. It spits out flares and coronal mass ejections. Trying to find the signal of a dark companion object next to the sun is like trying to hear a whisper while standing next to a jet engine. This is why the verification window is so stressful. Every time the sun burps or flares during November 2025, the scientists will jump. Is that it? Is that the signal? Then they will analyse the data. No, that was just a normal sunspot. The tension builds day by day. November 10th. Nothing. November 20th. Normal solar activity. December 1st. Still waiting. It is a waiting game. We are looking for a pattern that breaks the randomness. We are looking for a signal that is statistically significant, meaning there is less than a 1 in a million chance that it's a coincidence. The tension of the calendar. As the pages of the calendar turn, the tension in the scientific community will rise. If we reach December the 31st, 2025, and the sensors show nothing, absolutely nothing, then we have to face a hard truth. The theory might be wrong, or perhaps the object is further away than we thought. But if we do see it, if the sensors light up, if the gravity of the sun shifts just as the equations predicted, then the world changes overnight. It will start as a ripple in the scientific community, emails flying back and forth. Did you see that data from the Chile Observatory? Yes, confirm it with the satellite data. Then the announcement. This window is not just about finding a new planet. It is about validating a new understanding of our place in the universe. It is the difference between thinking you are alone in a dark room and suddenly realizing there has been someone standing in the corner the whole time breathing quietly. We are currently standing on the edge of that window. The telescopes are polished, the computers are humming. We are waiting for the clock to strike. We are waiting for the signal to rise out of the noise. Inside the deepest levels of administrative buildings where the air conditioning hums a little too loudly and the fluorescent lights buzz with a clinical whiteness, there is no smoke-filled room. There are no villains stroking cats or men in black suits laughing about what they are hiding from the world. Instead, there are exhausted people sitting around a mahogany table staring at a screen that shows data they cannot explain, terrified of making the wrong move. This is the reality of institutional silence. To the public, the lack of information looks like a grand conspiracy. It feels like a deliberate wall built to keep humanity in the dark. But to the people inside NASA, the Pentagon, or any major space agency, the silence is not a weapon. It is a shield. It is a pause button, pressed by fear, responsibility, and the crushing weight of history. Imagine you are the administrator of a space agency. A signal comes in. It is not random noise. It has structure. It has a mathematical pattern that suggests intelligence. Your heart races, but your training kicks in immediately. The very first rule of science is skepticism. You do not announce a discovery until you are absolutely certain. In the world of astrophysics, certainty is a brutal standard. It is not enough to be 99% sure. You need 5 sigma confidence, a statistical standard, meaning there is only a 1 in 3.5 million chance that the data is a fluke. If you announce that humanity is not alone and you are wrong, you destroy your institution. You lose your funding. You lose the public's trust. You become the person who cried wolf on a cosmic scale. We saw this happen with the arsenic life debate or the claims of bacteria in Martian meteorites in the 90s. The backlash was severe, so the first layer of silence is simply the scientific method moving at its natural glacial pace. They check the cables, they check the software, they check the telescope itself. They ask other observatories to look. This takes months, sometimes years. During that time, the outside world hears nothing. Then comes the second layer, the sociological fear. This is often referred to as the Brookings Report scenario, named after a study commissioned by NASA in the 1960s. The study suggested that facing a superior civilization could cause our own society to collapse. Institutions are designed to maintain order. They are designed to keep the stock market stable, to keep the power grid running, and to keep people going to work in the morning. The people in that boardroom asked the hard questions. If we tell the world tomorrow that an alien craft is entering the solar system, what happens to the global economy? Do the stock markets crash? Do people stop paying their mortgages? Do religious institutions face a crisis of faith that leads to unrest? Panic is the enemy of governance. A government can handle a war, a pandemic, or a natural disaster because there are plans for those things. There is no playbook for first contact. The silence, therefore, is an attempt to buy time to write the manual before opening the box. There is also the heavy, cold reality of geopolitics. This is the aspect that idealists often forget. If the object detected is a piece of technology, it represents the greatest strategic advantage in the history of warfare. If the United States releases data about an advanced propulsion system, they are also giving that data to China, Russia, and every other nation. In this context, silence is a matter of national security. It is the prisoner's dilemma played out on a galactic stage. If you share the information, you might unite humanity, or you might give your rival the key to a weapon that makes your entire defense system obsolete overnight. No general or defense secretary is willing to take that gamble lightly. They will classify the data not because they hate the public, but because they are paid to be paranoid. They lock the files away because they are afraid that if they don't, they are handing a loaded gun to an adversary. This brings us to the process of the press release. This is where the conspiracy is actually just bureaucracy. Picture a draft statement being written. It starts out clear, "We have detected an anomaly." Then it goes to the legal department. They change anomaly to unidentified phenomenon. To avoid liability, then it goes to the scientific review board. They add qualifiers like potential and theoretical. Then it goes to the political strategists. They are worried about the upcoming election or the budget vote. They cut out anything that sounds too alarming. By the time the statement is released to the public, it has been edited by 20 different people, all with different fears. The result is a bland, confusing, watered-down paragraph that says almost nothing. The public reads this and thinks they are hiding the truth. In reality, the truth was just filtered through so many layers of caution that it evaporated. The silence is also born from a lack of vocabulary. We expect our leaders to have answers, but in this scenario, they are just as clueless as the rest of us. To admit we do not know what this is a sign of weakness in politics. Leaders are supposed to project control. An alien presence represents the ultimate lack of control. It is the realization that we are not the landlords of the universe, but merely tenants in a very small apartment. To announce this requires a humility that is rare in the halls of power. Finally, consider the human element. The people holding this secret are fathers, mothers, and citizens. They go home at night and look at their sleeping children, wondering if the world has fundamentally changed. They feel the burden of being the gatekeepers of reality. It is a lonely, suffocating position. They are not twirling moustaches and laughing. They are likely losing sleep, taking antacids for their ulcers, and staring at the ceiling at 3 a.m, paralyzed by the magnitude of what they know. So when the radio telescopes go quiet, or when a live feed from the International Space Station is suddenly cut, it is rarely a malicious act. It is a reflex. It is the institutional equivalent of closing your eyes when you are about to crash. It is the hesitation of a parent trying to decide how to tell their child that the world is not safe. It is fear pure and simple, the fear that once the words are spoken, the world as we know it ends and a new uncertain one begins. The silence is not a locked door, it is a pause for breath before the plunge. For decades, humanity has looked up at the stars and asked a single lonely question: where is everybody? We build giant metal ears to listen for radio signals. We send out golden records with greetings in 50 languages. We flash bright lasers into the deep darkness. We are like a child standing in the middle of a dark forest shouting, "Hello!" at the top of our lungs, terrified that no one is there to answer. But there is a different possibility, one that is much quieter and perhaps much more unsettling. What if the forest is not empty? What if the forest is full of eyes, but they are simply choosing not to speak to us? This brings us to a concept often called the zoo hypothesis. To understand this, we must stop looking at the universe from our own point of view. We have to stop thinking like humans and start thinking like a civilization that is millions of years older than us. Imagine you are a scientist studying a dense jungle on Earth. You find a group of chimpanzees living in a remote valley. These animals have their own society. They have fights, they care for their young, they hunt for food, and they use simple tools like sticks. As a scientist, what do? Do you run into the middle of their group, wave your arms, and try to teach them mathematics? Do you give them smartphones and explain how the internet works? Of course not. If you did that, you would ruin the experiment. You would destroy their natural way of life. Instead, you hide. You might wear camouflage clothing that matches the leaves. You might use hidden cameras or fly a silent drone high above the trees. You watch, you take notes, you observe them in their natural habitat. To the chimpanzees, you do not exist, Tone. They go about their day thinking they are the masters of their valley. They have no idea that a superior intelligence is hovering right above their heads, watching everything they do. Now look up at the night sky again. To a civilization capable of traveling between stars, we are the chimpanzees. This perspective changes everything. It suggests that the great silence is not because no one is out there, but because they are following a rule. Perhaps there is a galactic law, like a prime directive, that says do not disturb the primitive civilizations. This is the idea of the nature preserve. Just as we fence off huge areas of land to protect tigers or elephants, maybe our entire solar system is a protected park. Earth is not a player on the galactic stage. Earth is a cage. It is a cage without bars, made of distance and ignorance. Consider the image of an ant colony. You are walking down the sidewalk and you see a line of ants carrying crumbs. You are thousands of times larger than them. You are thousands of times smarter. You have the power to step on them and end their world in a second. Or you could bend down and give them a pile of sugar, making you their god. But usually you do neither. You simply walk past. You are indifferent. You do not hate the ants, but you do not love them either. They are just there. If the ants could think, they might wonder why the giant walking by didn't stop to say hello. But the giant has nothing to say to an ant. The gap between your mind and the ant's mind is too big. There is no conversation to be had. This is the cold reality of the silent observer. We like to think that if aliens found us, they would be fascinated by us. We think they would want to judge our art, critique our wars, or solve our math problems. But a civilization that can bend gravity and harvest energy from stars might look at us with the same bored indifference we feel when we look at bacteria in a drop of water. They might be watching us right now, but they are not watching with human eyes. Imagine a probe or robotic machine sitting at the very edge of our solar system. It is small, dark, and cold. It has been there for 5,000 years. It arrived when the Egyptians were building the pyramids. It watched the Roman Empire rise and fall. It watched the world wars. It watched the first human walk on the moon. It does not judge. It does not feel happy or sad. It simply records data. It sends a stream of information back to its home light years away. To the creators of this probe, our history is just a television show. Maybe we are an interesting biology project. Maybe they are waiting to see if we destroy ourselves with nuclear weapons or if we manage to survive. They are curious, but they are not involved. This theory explains why we don't see them. If they are advanced enough to travel here, they are advanced enough to hide. A stealth drone today can fly over a village without being seen or heard. An alien probe would be millions of years more advanced. It could be the size of a dust grain floating in our atmosphere. It could be hiding behind the moon. It could be cloaked in ways we cannot understand. If the zoo hypothesis is true, it solves the Fermi paradox perfectly. Where is everybody? They are in the spectators' seats and the lights are off, so we can't see them. There is a chilling comfort in this. It means we aren't alone. But there is also a deep humiliation. Humans have always believed we are the center of the story. We believe we are the main characters. But in this scenario, we are not the explorers. We are the indigenous tribe on an isolated island throwing spears at the ocean while invisible ships sail past just over the horizon. It implies that we are not ready. We are too violent, too loud, and too simple. Why would a civilization that has solved the mysteries of the universe want to talk to a species that still fights over borders and burns fossil fuels? It would be like a Nobel Prize winner trying to debate philosophy with a toddler. So the silence continues, not because the galaxy is empty, but because the galaxy is polite. They are waiting. Perhaps there is a sign on the edge of our solar system written in a language we cannot read yet. It warns travelers to keep their distance. It says, primitive species evolving do not touch, observe only. And so they watch. They watch our cities glow at night. They watch our radio waves leak out into space. They watch us look for them. And perhaps that in their cold alien way they are rooting for us to grow up. Or perhaps they are just waiting for the show to end. We have travelled a long way together in our minds. We began this journey by looking through a telescope, spotting a strange flicker of light moving against the backdrop of the stars. We watched as that object, which we called Atlas, tumbled through our solar system. We asked questions about its shape, its speed, and its origin. We wondered if it was a rock, a shard of ice, or a machine built by distant hands. We analysed the data and debated the theories. But now, as our journey comes to a close, it is time to put down the telescope. It is time to put away the notebooks and the calculations. It is time to simply lean back and look up. The story of Atlas is not really about a specific object. It is not about rock or metal. It is a story about us. It is a story about the feeling you get when you stand at the edge of the ocean at night, unable to see the other side, knowing that the water goes on forever. Atlas was a reminder that the ocean of space is deep and we are just standing on the shore dipping our toes in the water. Think for a moment about the sheer scale of what we have discussed. When we talk about the universe, we often use numbers that are too big to truly understand. We talk about billions of years. We talk about light travelling for centuries just to reach our eyes. These are not just numbers, they are a measure of humility. When we look at a visitor like Atlas, we are reminded that the universe has been here for a very long time before we arrived, and it will be here for a very long time after we are gone. This might sound frightening to some, but there is a deep comfort in it. It is the comfort of being small. When you realize how vast the cosmos is, your personal worries begin to shrink. The stress of the day, the deadlines, the noise of the city, all of it seems to fade away when compared to the silent, majestic rotation of the galaxy. You do not have to carry the weight of the world on your shoulders. The universe is carrying you. You are a passenger on a beautiful blue sphere drifting safely through the great dark. Regardless of what Atlas actually was, it taught us that we still have so much to learn. There are still mysteries waiting in the dark. Some people fear the unknown, but the cosmic perspective teaches us to love it. The unknown is not a place of danger, it is a place of possibility. It is a library filled with books we have not read yet. It is a song we have not yet heard. The fact that we do not know everything is a gift. It means the adventure is not over. It means there is always something new to discover, something new to dream about. Now let your imagination drift away from the hard facts. Visualize the night sky above you. Imagine the ceiling of your room dissolving, fading away like mist, revealing the velvet darkness of space. It is a deep, rich darkness, calm and still. Scattered across this darkness are the stars. They are like diamond dust sprinkling a soft silver light over everything. Some of those stars are burning bright and hot. Some are old and gentle, glowing with a warm orange light. And in between them there is the silence. Space is not noisy. It is the quietest place you can imagine. It is a silence that wraps around you like a heavy warm blanket. It is a silence that invites you to rest. Imagine that object Atlas moving through this silence. It has passed the sun. It has passed the orbit of the outer planets. It is now drifting into the deep void between the stars. It is moving away from us, tumbling slowly end over end into the forever. It is not lonely. It is simply a part of the dance. It floats effortlessly without engines, without struggle. It just is. You can be like that too. You can stop struggling. You can stop trying to figure everything out. You can just be. Like a star, you have a place in this universe. You're made of the same stuff as the stars. The atoms in your hands, the iron in your blood, the carbon in your breath, it was all cooked inside ancient suns that exploded long ago. You're not separate from the universe. You are a child of the universe. You belong here. Feel gravity upholding you gently. This acts as the invisible hand of the planet, keeping you safe, anchoring you to your bed. You are secure. You are grounded. While your mind floats among the stars, your body is safe here resting. Think of the earth turning slowly beneath you. It rotates smoothly, bringing the night to your part of the world. The birds are asleep. The winds are settling down. The busy energy of the sunlight has been replaced by the cool, calm energy of the moonlight. Everything is slowing down. The breath in your lungs is like the tide of the ocean. It comes in and it goes out. In and out. A slow, steady rhythm that has been with you since the moment you were born. Let your breathing match the slow rotation of the galaxy. There is no rush. There is nowhere else you need to be. The past is a memory and the future is a dream. All that exists is this moment of peace. Let the image of the stars become softer now. The sharp points of light are blurring slightly, becoming gentle glows. The darkness is warm and inviting. It is the darkness of sleep. It is the darkness of rest. We look up at the sky, not to find answers, but to find peace. We look up to remember that we are part of something huge, something magical, something eternal. The mystery of Atlas is just one page in the endless story of the cosmos. And tonight you can close that book. You can put it down on the bedside table. You can let your eyes close. The universe will keep spinning while you sleep. The stars will keep shining. The planets will keep dancing their slow, wide circles around the sun. You do not need to watch them. They know what to do. You can let go. Drift deeper now. Deeper into the comfort of the unknown. Deeper into the quiet. The questions are gone. The curiosity has turned into contentment. You are safe in the vastness. You are a small, precious part of a magnificent whole. Good night to the stars. Good night to the wandering rocks and the distant comets. Good night to the moon. And good night to you. May your sleep be as deep and as peaceful as the space between the stars.